Hello there, welcome to Unit 3. This one is all about Newton's laws. So this section we're dealing with forces, teach what they are, and let's just go right into this. So the purposes for this lesson, we are going to define what are forces. We're going to discover the differences between mass and weight, and we're going to learn about the force of gravity. So a force is a push or a pull that's going to be acting on an object. So anything that's pushing or pulling an object, that is defined as a force. The units for force are newtons. So there are four fundamental forces that make up all the forces in the universe. We've got gravity is one type of force. We've got electromagnetic force. We've got the strong nuclear force and the weak nuclear force. In this unit and in this course, we're really only going to focus on gravity. If you get into Physics 12, we'll have gravity and electromagnetism. And the strong and weak nuclear force, those are more chemistry-based stuff, and I haven't dealt a lot with it, but you'll see that more in chemistry. So mass versus weight, we want to know what's the difference between these two. Force of gravity, this is the attraction between matter. Mass is the amount of matter in an object, so the amount that makes up something. Whereas weight is the force acting on an object by gravity. So these two things are different. Mass is the amount of matter. Weight is the force that's acting on it by gravity. Mass is constant anywhere you go, but weight will change depending on where you are. So I'm sure many of you have a scale in your bathroom where you can measure how much you weigh, or at least that's what you say, is that you're measuring your weight. But really when you go onto the scale, it's going to give your answer in kilograms. It's going to tell you a mass. Now, it's not that you're actually measuring your mass, even though the answer comes out as mass. You're measuring the weight. Because if you were to take that scale and go on the moon, say, and you measured your weight there, it would be totally different. So I would say your mass would be much, much smaller than what it actually is. And that's because the amount that gravity is pulling you down, that is your weight. So you're measuring weight, but the scale automatically converts that into mass. It's tricky because we use the two things interchangeably. You say, what's my weight? And then you give kilograms, which is not technically true. So force of gravity, here's your equation for it. Fg, force of gravity, is mass times g. So these are the definitions of these three things. So force of gravity, that's Fg, it's measured in newtons. You've got your mass is in kilograms, you should know that one. G is what's called the acceleration due to gravity. And on Earth, it's 9.8. You know this value already from kinematics. So G varies depending on the size of the planet you're on and how close you are to its center. So we've always said G is 9.8. You might have seen questions last unit or the unit before where we were dealing with the moon where G is 1.6, or there's some other values for G. So for example, we've got on Earth at sea level, it's 9.8. If you're at the equator, it's going to be slightly less. If you're at the North Pole, it's going to be slightly bigger. On the moon is 1.6. If you were to go to Jupiter and stand on its surface, it's 24.5. And if you somehow manage to stand on the sun's surface, the G would be 274 meters per second squared. So G depends on lots of different things, and that's going to affect your force of gravity. So if you're on the Earth's surface, you're going to have a different force acting on you than on the sun. On the sun, you'd be squished and really hot. So that's it. This is a very short video all about forces, introduction to forces, and hopefully that all made sense.